Uh, Very good. So I'm going to speak a little bit about this thing that the note that Franta ended on about the components that form part of this ecosystem of mapping applications. And I'm going to talk about something called Map Whiteboard. And this is not something that I have dreamt up alone. It is the collective product of many different organizations, out of which Plan for All associations, ECSS, LESS, Project BOSC, and Wireless Info form part in alongside ourselves. I am Runar. I work for a Norwegian company called Asplan Viak Digital Services. I've been around on this planet since 1974. I've been working with spatial planning and GIS since 1995. I've been traveling much more than what is sustainable since 1998, and I've been working for the company that I work in now since 2001, and I work out of Brussels. My specialization is in research and development, focused around areas like land use planning, natural resource management, and system development related to those. And I work a lot towards the agricultural sector, a lot towards environmental impact assessment, and so on. I've been working quite a bit around the world, not too much in Argentina, I regret to say. I think the closest I've worked to your place is in the neighboring country, and also not very close in Chile. But I've been working in Viña del Mar for some projects. This map whiteboard is essentially inspired by Google Docs. Back in the dark ages, when we were collaborating on writing documents for proposals or research articles or whatever it might be, the administration of coordinating work was rather dramatic. It was a lot of work to bring together content, and process very slow. A lot of, very difficult. But with this arrival of Google Docs many years ago, suddenly we could be 10, 20, 30 editors working on the same document, which in one way is a nightmare, but on the other hand makes it possible to create text content very efficiently distributed on many people. So while we were sitting with this, writing proposals about GIS and enjoying the fact that we were now able to make 100-page documents collaboratively, we thought, okay, we're all working in GIS. How could this be put to use in the context of GIS? How could we work in a map the same way that we work in a text document? And we came up with this concept of the map whiteboard, which is meant to take away and digitalize some of those processes that we normally do in meeting rooms over maps. So if we imagine a very typical process which involves a lot of maps, and one that many of us will have had a relationship to, let us take as a starting point a landowner who has a piece of land and wants to do something as ill-guided as building a house. Now, there is very little happiness that comes from building houses, but she doesn't know this yet and she wants to do it, so she files a permit application. Okay, maybe the permit has now been digitalized, so she can submit this electronically, but nonetheless, it is still a matter of asking to do something in a location. Now, depending on which country, which legislation you operate in, this permit is submitted to one entity, and this, so let's say, for example, a local municipal planning office or a county planning office, and then it's this office that coordinates with all the other entities that needs to approve this permit. But in other countries, it's the poor landowner's problem. They have to run around to 70 different agencies and get a letter saying that, okay, there is no conflict with the roads, there is no natural risk zoning here that makes it dangerous to build. There is no utilities issues. You have gas, you have electricity, you have water, and there is no environmental impact from this measure. And in all of these instances here, either people are sitting with this location and their own map systems working independently. Every one of them have 3 weeks to get back to this person here. That's by law, 4 weeks, 5 weeks, depends on the legislation, but they have a lot of time. Whereas this poor person who is out here, the landowner, may not have so much time and may not be quite so eager to wait for all this. So we have a situation where things take time. So what we want to do, we want to make a system that replaces this person and allows all these entities to work together as if they were in the same meeting room over the same table, sharing their maps, sharing their knowledge, coming to a decision much faster. So that is sort of the philosophy and how to use a Google Maps type of technology to achieve that. So we have then put together a concept where we have a tool that is supposed to work both for GIS professionals, but also from professionals in other fields and regular people. It's going to be a web-based client, and it's going to work towards a server that will allow me to see what is happening when other people are showing me their maps. And we have some different elements of this architecture that I will zoom in and look at. So if we start with this everyone, who is the everyone? Well, in this process that I just described, it could be a planner, it could be someone who owns or manages some utilities, gas pipelines or water supply, or an analyst or a farmer for that matter. Anyone who is not a hardcore JS expert, but to someone who has some relationship to maps and location in their life, but that's it. Or it could be someone who's non-professional. It could be a citizen or a resident, a visitor to an area. So referring to your question about tourism maps and after the previous presentation, or someone in school. So people who would like to see where something is located or to find something, people with a simpler approach to maps than the GIS user. The GIS user, on the other hand, this is a sort of person who has all this language of GIS under his skin. They are talking about maps and themes and datasets and data sources as if this was part of the basic education of every child that was ever born. Whereas all this language is really inherited from a 40-year process of development of desktop GIS with ArcGIS and QGIS and this sort of universe as the home. So we want to make a platform that enables both the people who use Google Maps and the people who use ArcGIS or QGIS to come together. So where do they meet? They meet in the Map Whiteboard web client. That is an HTML5 application, which runs exclusively in the browser, exactly the same platform essentially as Hub for Everybody that František just showed. If you visit it, you will go to a landing page that introduces the concept, has a demo video, and has information on how to get started. But the life and blood of this is a content manager application where you're able to upload, edit, create maps in the same manner that you go to Google Drive and create a document. And the metadata for these maps are exactly identical to the ones that František showed in the previous presentation. So you have a map with a predefined content, with a predefined area. Each of these get a unique URL, similar as a Google Docs URL, and you can share this one to anyone and subject to access control, because you can decide who is allowed to see this, if it's public or if it's for specific individuals who can read only, who can write. Anyone who gets this link and who has the rights, or you have given the rights to, they will be able to see and interact in this as it were in a regular Google Docs document. So next, you have the map application, which looks also identical to the ones shown previously. It's based on the exact same client, hence the similarity. Now we need to think in the text document. Of course, what we need to see is I need to see where people are working right now. So I need to see the cursor of people, and I need to see the text they're writing, and that's sort of the limits of what you need to see when you're editing a text document. So now we have to think, what is it that we need to see when we are sharing a map? Well, if you imagine these different actors that were going to approve the building permit, they are typically people who sit around the table and point with their fingers or draw with fluo markers to illustrate on a map where there are issues and where there are feedback, proposed changes. So the first thing we need to do is we need a way to see where people are pointing. So we need to see the cursors of those people who are working on this map now. So if I move my mouse over the map, I should be able to see where other people move their cursors so that we can point to things, can discuss them efficiently. Second thing, we need to be able to draw and modify. So let's say my building permit has been uploaded as a GeoJSON file, maybe. Now there is problems with it, but the problems can be solved by shifting the application by a meter to left or changing the shape a little bit of the proposed area. And we are able to upload the GeoJSON. I can make a modification to it. Another party can make a modification to it. So now we have replaced the fluo marker. Now we have replaced the annotation on the map that people would do in this meeting. Then the next thing we find in these meetings is that, okay, I'm responsible for water utilities. Someone else is responsible for fire hazards or for geotechnical stability. So all of these people bring their own data to the table. And historically, they did this as big printed paper maps, and they stacked map on map and more paper, and it was sort of, a nightmarish combo. In reality now, many of these data exist as WMS services. So in addition to being able to point and annotate, edit data, we have the flexibility of uploading data sets. So if I'm responsible for utilities, I can upload a couple of layers of WMS services that will show utilities in the context of the building permit. This way, I'm able to bring my information into the mix. And if everyone does this collectively, it is possible within a very short span of time to make a feedback and shorten the loop required for obtaining a building permit, for an example. Now, the building permit is just an example. We'll come to some other use cases afterwards. So that is the client. Now, what is required on the server to make this magic happen then? Well, we need to have a mechanism to exchange all these cursors. So I move around. If I want to see my cursor move in a nice way, not jumping around the screen like crazy, but moving smoothly and nicely, I need to send an update to all the other computers that are looking at this map, maybe 15 times per second, 10 times per second, 15 times per second. That will be roughly the same movement speed as a cartoon. You can see my cursor, I can see yours. I can add a feature. I can draw a polygon or a line or a point on this map. You can see it. And a third person can connect and edit, add an attribute to it or edit, change the shape of it. I can add a map. We need to transfer these maps. They need to travel back and forth. I can add one. You will see it. You can turn it on and off, etc. The technology of this is based on Node.js and MongoDB. It might be tangentially interesting. I'm not going to go much into that. But the three standards that are sort of essential to achieve this is GeoJSON, that is used to transport the cursor movements, as well as to transport the spatial data that we create together. We are describing them in GeoJSON. My cursor is currently at latitude, longitude, something. This is transferred to all the clients. Then we have the challenge that we don't want to share only a data set. We want to share the whole map. So there needs to be some format that describes a map. Now, in the OGC universe, there exists the web map context and the OVS context service, but none of them would allow the type of interaction that we require to be able to add and remove layers and to be able to create data. So we have made our own format for describing maps, which is called map compositions, a JSON format, which is the same one that Franta described the published maps in Hub for Everybody. And finally, we use WebSockets, which is a very efficient technology that keeps an open connection between you and the server all the time to transfer messages. When you load a web page, you open a connection, 20 connections, and then you load some data and it closes. But sometimes when you are in a place with slow connectivity, you see that it takes some seconds before you get a connection, and then maybe the data loads a little bit slowly and then it's closed. And next time you load, the same thing happens. WebSockets keep an open connection between you and the server at all times, so data travel very, very efficiently. Then we had the challenge, once we've been working for some time, that we want this to be a meeting place between both the expert GIS users and the tool that can suit everyone. And this is a difficult order. We are satisfying both vegans and meat eaters at once. It's not easy. So we conceived that there is necessary to have a desktop client for this too. And that is because if we want to use this in a context where people are supposed to do something more complicated than pointing at a map, drawing on it, and showing some layers that they may have themselves, if we're going to offer people something more complicated, then typically I will have to do some analysis that I share with others. So we have two choices then. We could either try to make this web client more and more complicated at the risk of ruining the user experience for the simple users, I mean the users who are not GIS experts, or we could make a plugin for a professional GIS tool like QGIS that would allow us to have an asymmetric operation where I, as an expert, sit in QGIS. I do my analysis. I run maybe complicated scripts and models that I have created. And once these models are finished, I can share the results of them as maps in the Map Whiteboard with anyone who is able to view and interact with them through the web browser. I'm in QGIS, they are in the web. So that is the principal justification for that application. This has been quite a long time in the making, but then again, it's not so easy to do it much faster under the circumstances. What we're trying to do now is to develop some more business cases for this technology that we are going to use to bring it from an advanced late stage scientific experiment to becoming a production grade commercial or public service for that matter. So one of the areas that we're interested in is the uptake of more sustainable farming practices. And for medium-sized and large farms, we believe precision farming to have an important role in that. But we observed that for the past 30, 40 years, even though the concepts sort of were known, at least let's say 25, 30 years, even though the concepts were well known, the adoption is very limited. And we believe this is because, as it is today, farmers, of course, they interact with agricultural advisors, and agricultural advisors can tell them that maybe smart farming is something for them. But if they go to the equipment manufacturers, they will offer them a solution where A satellite will collect some data. This will go into a wonderful black box of which the farmer is completely unaware and the agricultural advisor is completely unaware. This will then again produce variable rate control data that will be sent to the hardware, to the tractor or to the fertilizer spreader or the irrigation machine, and this will then be applied to the land. But the problem, of course, is that the farmer is not quite enough of a simpleton to just agree to this, because the process is not disclosed and the process doesn't take into account local conditions. Once again, this is a place where we believe the Map Whiteboard might have a function. Putting a shared experience where the farmer and the agricultural advisor can work with the land together, using satellite data, using data for the specific property, to conduct analysis collaboratively, to factor in the experience of the farmer, and also to achieve that very critical element of involvement, transparency, because farmers will not adopt something that is magically produced by a black box sold by someone in a suit from a different country. So essentially, this is the necessary thing. And then from the Map Whiteboard application or related analysis models, one would generate the variable rate data that actually goes to the control of the equipment, factoring in experience alongside automated analysis. During these 2 last years, we've had a massive increase in online meetings, maybe too massive, many people would say. I write since the pandemic because we have sort of decided that the pandemic is over, in Norway at least, whereas it is very much ongoing. But nonetheless, people have become very, very comfortable in online conferences, much more so than they were before. And part of that means that a lot of people who used to come together and stick yellow stick-it notes on the walls and draw together a lot on whiteboards and on walls and whatever it might be, they have now started to adopt a number of these augmented meeting tools. Augmented, what is this? Is a fancy word for something in addition. So some shared workspace. And Mentimeter offered the possibility to vote on things alongside meetings. So you had some sort of a second layer of interaction between the meeting attendants and the people. And Miro allowed something that's very similar to the Map Whiteboard, but which has no spatial dimension whatsoever. It has tables. It's just a huge, fantastically huge desk where you can make as much mess as you like, but it's become fabulously popular. So the fact that people are starting to become familiar with this means that there is a rather great opportunity for the Map Whiteboard by integrating it with as plugins to existing conferencing tools. So not necessarily having to be a marginal or little known mapping technology, it could become a rather more well-known plugin technology to Teams, to Google Meet, or to Zoom, the major conferencing platforms. So that is the 2 things that we are presently working on, and we are in the late stages of making this commercially available. When I say commercially, I mean, I'm not talking here about vulturism. We are not looking to exhaust the resources of the world, but production grade, something that has a quality and a reliability and a robustness that people can use it for professional purposes is what I mean by commercial in this context. Now, that concludes more or less what I had planned to say. And then Franta said 1 week ago, at least, that he would provide a demo of this. I don't know if he still says this, but if he does say this, I have made this slide as a placeholder for this demonstration. And for my own sake, I will merely say thank you very much for the attention, if you paid any, and say that it was nice to have the opportunity to speak to you, and I hope that our paths shall cross, preferably in Argentina rather than here, because in this time of the year, our thoughts, minds, and hearts drift towards places on the planet that are more pleasant climatically. Okay, Frante, would you like to give some small demo of this, or?
I guess I could make like 2 minutes demo.
Yeah, just to show how it works.
Yeah, I will.
Then I will give away the screen.
Mm-hmm. Okay, so hopefully it's visible to you, or?
You can see two screens.
Okay, so I would like to just shortly show you what Runar has beautifully described. What you see on the left is the web client. So that's the web application you can open anywhere in your browser. What you see on the right is QGIS. So that's the heavyweight in GIS. That's the very powerful software you can use to work with your GIS data. You can see that I have opened the same app, and as I'm moving with my cursor in the QGIS, you can see that the cursor transfers also as in the form of a point into the left into the web browser application. The same would be if I move here into the web browser, it transferred the cursor position into the QGIS. So that's the first interaction Runar has mentioned. The second interaction would be, and that would be the field for example, agriculture advisor, where you use QGIS as an analysis tool to share something with the other clients, with the other parties in the conversation. So you can see that I have a layer of water bodies again here. I use the same data as for Hub for Everybody demonstration, and I can run some simple analysis on this layer. So QGIS offers some basic analysis for geoprocessing. I can, for example, want to create a protected area around the water bodies. So I can use the geoprocessing called buffer here, which will create a buffer geometry around the water bodies. Let's say we want the buffer to be 500 away from the water bodies, and I run the analysis. The analysis executed successfully, and you can see that I have a new layer here that's called by default buffered, and you can see it also in the map. That's this buffered layer. And if I move to the web, this new layer suddenly appeared even in this client, even in web browser, and you can see the geometry here. So that's the other type of interaction that you can see in Map Whiteboard. And of course, it can be handy. It can be handy if the communicating parties can point not just with the cursor, but can point even with some drawing, with some sketches, or so we have a. To be honest, this tool is still in development. It's quite new tool, so it still has some bugs or issues. But I can select into which layer I want to make my sketches, and then I can simply select the tool I want. I can draw points or lines. I can draw some shapes, and I can draw the shape into the map. And you can see that it's suddenly, or it's in the second it's synchronized to the QGIS client. One of the missing features you have probably noticed is that the symbology of those two clients is not synchronized yet. So that's actually one of the features we are working hard on right now, and I guess it will be available in like 1 or 2 weeks. So if I make a blue line here, it should be a blue line even here, not green. I hope you can see it. I can change the color. Yeah, those are the lines. So that's the third type of interaction that was described by Runar, and I guess that's basically it. Yeah, that's the.
I think that demonstrates well the concepts, and if you imagine this now applied to processes where multiple parties are involved in studying a single area, be it a building process, be it a agricultural analysis for variable rate applications, or be it a any purpose data capturing operation where you need to have someone who knows something about maps and someone who knows something about the field, where you are able to effectively collaborate online in a combination of voice by seeing the cursor, interacting in the maps, sharing the information. I think there's little else to add.
Yeah, just one more remark on the end. You can see that we also have this panel of the history of activities, so you can actually browse through the history, what was changed in the map, and you can either revert it or you can zoom to the changed feature. So that's all from my part as well.